So in this video we're going to look at the June 2015 calculator paper. I strongly suggest that you have a good look at each question yourself first and give it a try, and then skip forwards and backwards on the video to the question that you want to look at. So let's have a look at the formula sheet now. Well, I've written a few notes on here for you. If you want to know the volume of a cylinder, you can use this first one here. That is a help because you can imagine that this is the circular part of the base of the cylinder and you can just times it by the height. With the area of a trapezium, if you imagine h times b would give you the area of a rectangle, which was too much. And if you looked at h times a would be an area that wasn't enough, then hopefully you can appreciate if I do the average of these, I will get the area that I actually want, and that's always the case with a trapezium. So if you took out a factor of h, you'd get a plus b all over 2, which is exactly what you're given here. So keep that in mind. As I've said before in a previous one, if you know that this is given, then if you want the angles, you can just do sine A over A is sine B over B, and so on. So you can invert every part. This one, think of it as a squared is b squared plus c squared. So it's basically Pythagoras, but with a little correcting factor. And then lastly, the formula, if you split it up in this way, you can see the line of symmetry and then the discriminant separate. As one other thing, if you look at this one here, if you imagine there was a cylinder with exactly the same height, then if you melted down 3 of these cones, you would fill up the entire cylinder. So if you know the volume of a cylinder, which is pi r squared h, then if you want the volume of a cone, then you can use Archimedes' principle, and it's just a third of what the cylinder would be, and you can see that just there. Okay, so we've got to look at some probability here, and we've got to firstly write down the probability that the sweet is a dark chocolate caramel, and one is taken from the bag. Well, there's one dark chocolate caramel sweet from the table, and there are 30 sweets, so the probability of choosing this dark chocolate caramel will be 1 in 30 chance. Okay, so 1/30th, you're not supposed to write 1 out of 30 like this. Or this. It would have to be a fraction, decimal, or percentage, and in this case the percentage is perfectly fine. So the second part of the question says, work out the probability that the sweet is a white chocolate. Well, here we have 4 of the caramel type, 1 of the strawberry type, and 4 of the nut type. So if I just do those in a different colour, they're all white chocolates. So you've got 4, 8, 9 of them out of 30 choices. You could cancel that down. You're not going to get any extra marks for it. But 9 out of 30, if you think about it, 9 is 3 times 3, and 30 is 3 times 10. So if you cancel, you can also say an equivalent fraction is 3/10, or 30%, or 0.3, but that will be absolutely fine in this situation. In this final part of the question, you've got to work out the probability that the chocolate is a white chocolate that is chosen, and what you're given is the probabilities of the other types of chocolate being chosen. So you have 0.35, 0.17. So if you add those up, you get 0.52, or 52 out of 100, or 52% chance of those chocolates being chosen. So the probability of a chocolate being chosen at all will be 1, or 100%. So you have to see what is remaining. So how much do you think is left from 0.52 to 1, or 52% to 100%? Well, what is left is 48%, or 0.48 chance of the white chocolate variety being chosen. So that's that question hopefully done. Let's move on. Here we're looking at trial improvement, and if you don't show your working, I know on the mark scheme it would always say no marks whatsoever if you just put the answer. So don't rely too heavily on the calculator only and then show nothing on the page. And you know, when the examiners say all, it's telling you you're going to get nothing if you show nothing. So we'll start with 3, and that would give us 3 cubed minus 3 squared. And if we try that on the calculator, so we have 3 cubed minus 3 squared, and that will give us 18. And then I'd put an arrow here saying too low. Okay, then we can go, leave a bit of space and try 4, and then 4 cubed minus 4 squared. That's going to give us 64 minus 16, which is 48, which is too high. Now, what I would suggest is, if there's a solution between 3 and 4, I would go halfway. It's called bisecting the interval. The interval being between 3 and 4, and this term bisecting comes up at higher level maths at A level. So there's no harm in using this idea of just going for the halfway measure first. So we'll try 3.5, and so 3.5 cubed minus 3.5 squared. It's a calculator paper, so it'll be fine if you just wrote that, and you'd get 30.625, which is a little too high. But if in this situation 3 was not enough and 4 was too much, and then even 3.5 was too much, then we might start looking in between 3 and 3.5. Now you could choose 3.25 halfway, but why not just take it a little lower and do 3.4 and see what that gives? The reason for this is that 3.5 was very close. So 3.4 cubed minus 3.4 squared, that gives 27.744, which is not enough. So what I think you should do next is to try 3.45 and see what that gives. And you've got a calculator, so it's not as if you're having to do lots of calculations, and that gives 29.161125, which is still not enough. So if you think logically now, if we had 3.5, which I'll write in orange here, and that gave us this situation, which is 30.625, then what we can safely say is, and that was too much, we can safely say that 3.46 could be even closer, 3.47 and so on. But 3.5 itself was too much, therefore to one decimal place we can safely say that 3.5 would be the answer. So I would be writing 3.5 here. And I'd write 1 dp. Well, in question 3, use your calculator to work out this expression, and you've got to write down all the figures on your calculator display. Well, I would definitely do the numerator first, so I'll do the square root of 70.25, and I'd write that down as a decimal, and I'd have 8.381527,307, and then I would do 4.2 minus 2.37 as the denominator, which is 1.83, and then I would do the whole thing over, and so I will now do 8.381527307 divided by 1.83, and my answer would be 4.580069,567. So we've now got to write our answer in part A correct to 4 decimal places. So first, second, third, fourth decimal place. So the 6 would round this 0 up to a 1. So the answer would be 4.5801, and I'd write that as 4 dp, 4 decimal places. In this question, we've got to enlarge the shape given by a scale factor of 2, centre A. So the best way I find of doing this is to draw some rays, and we'll have them in orange. So let's draw those. So there's one here, and what I'm going to do is I'm just going to make them go through the centre A, and I'm going to join the centre A and make it go through all the points on the triangle. So that's the first one, and then we can do another one, and then this will go through the centre A as well, but go through another point on the triangle. So here we are, making it look harder than it actually is. Let's get this dead right. Okay, painful to watch, I do apologise. And then the next one, the final one, like so. And there we go. Now we've got to enlarge the shape by a scale factor of 2. So if we just start with this length here, it's 2 at the moment. We want to make it 4 somehow, but it's got to go from this line here to this line here. So here I can see 3 and a bit. Here we go, 4. So if I join this up here and use a ruler obviously, then the corresponding length here, instead of being 3, should be 6. So let's see if it is. 1, 2, 3, 4, 5, 6. And then all you need to do, I promise you there's no tricks here, you just get your ruler and you just join the points up here from here to here. That's going to do one more go. Right, that's as best I can do with this pen. And there you go, there's your enlarged shape by a scale factor of 2. The interesting thing to note here is, as a little aside, if you have a length scale factor of 2, then can you remember what your area scale factor would be? Well, it will be 4, i.e. 2 squared. And what would your volume scale factor be? Well, it would be 8 or 2 cubed. So one thing I can do quickly is to just verify that if the length scale factor is 2, has the area gone up by a factor of 4? Well, the area of this triangle here, right angled triangle, is base 2 times height 3 is 6 halved, which is 3. So that's 3 units squared. And in this one here, the larger one, it's 1, 2, 3, 4 by 1, 2, 3, 4, 5, 6. That's 24. Halved is 12 units squared. So hopefully you can see that to get from 3 to 12, the area scale factor has gone up by not just 2, but 2 squared. So that's just worth mentioning. So in this question, we've got quality of written communication, and we've got to sort out how many students were sent by each school to a revision day. So we know that one school sent X students, another school sent twice as many as this school, so they would have sent 2X, and the last school sent 7 fewer students than the school we started with. So 7 fewer than X would be X with 7 taken away. So that would be the total number of students. Okay, so we can simplify that a little bit, and we can have 1x, 3x, that's 4x minus 7 students. So the nice thing about this question is it tells us how many students there actually were altogether, okay, because it says there was £1,155 paid in total, and each student paid £15. So you can use your calculator to do this, and you can get 77. I just want to try this without, so I'm going to double the top. So I'm going to get double the 1,000, that's 2,000, double the 100, that's 200, double the 50, that's another 100, so that's 2,310, and then double the denominator as well, and that gives me 30. Then I'm going to divide top and bottom by 10, so I'll have 231 divided by 3, and I know that 3 80s are 240, so I'm 9 short, and 3 3s are 9, so I'm going to have 80 with 3 taken off, which is 77. Or you could just do a division sum here. 3's into the 23 goes 7, 2 left over, and so on. I'm just highlighting this because whether you've got a calculator paper or not, don't lose sight of the numbers in the question. And when you're doing the non-calculator paper, you've got to not only revise calculator papers using calculator and not using a calculator, because it will just help your skills overall. So there's 77 students then altogether, so we should know now to say that the total number of students is 77, and we form this linear equation. We then add 7 to both sides, and we'd give our next line as being 4x equals 84, and so x would be 84 divided by 4, which is 21. So we know in the Redlands school x is 21, so we can write that here. So Redlands 21, then the St Samuel's school will be twice as much, which is 42, and the Francis Long School will be x minus 7, which is the 14. Always check to see whether it adds up, so we've got 4, 5, 6, 7, and then 1, 5, 6, 7. Okay, so that should be our answer. We've worked out how many students were sent by each school. Here we've got a quality of written communication question again, and we've got to work out which of the coffee sachets is the best value for money. So we just have to set our work out really clearly. Now, this is a calculator paper, so feel free to use your calculator, but I'm just going to explain it without to start with. So for the small, we would have £5.65 for 12 sachets, so I would do 565 divided by 12. So 4 12s, that's 48, with 8 left over. 7 12s are 84, with 1 left over, doesn't go in here. So 8 12s are 96, with 4. And then 3 12s are 36. So we've got 47.083, so to the nearest penny, I would say 47 pence per sachet here. We can round further if we need to later on. So let's go with now the medium. And this time we've got £9.20 for 20. So that's 920 over 20, which is 92 over 2, which is 46. So we have 46p per sachet. And then lastly, for the large, now you would expect the large in bulk to be better value for money, wouldn't you? But please don't just assume that. You've got to work it out. So you've got £15.75 for 35. So we've got 1,575 divided by 35. Well, 5s into 35 is 7. And then 5s into 15, that's 3. 5s into 75 is 15. And then 7s into 315, well, 7s into the 31 is 4. 4 7s are 28, remainder 3, and then 7s into the 35 is 5. So you can use your calculator, but you get 45p per sachet here. So it seems as though the larger of them is best value for money, and that kind of would make sense, buying in bulk. So that's best value. So best value, and just put large in there, so you've definitely got the marks. Okay. So in this question we've just got to expand an expression here. So we've got 7 lots of x and 7 lots of 5, not 7 and 5. So if you want to think of it, when that would be 35, if you want to think of it in a grid, like a times table grid, that will kind of prompt you to multiply everything, and you just fill the grid in. So you'd have 7 x's, you wouldn't write x7, you'd write 7x, x7 wouldn't exist. X to the power 7 is fine, but not x7, and then 5 7s are 35. So it would be okay if you wrote, this is equivalent to, you could write 35 add 7x, that would get you full marks as well. Okay? For this one, we want to expand 3y times 4y and 3y times negative 3. So personally, a grid doesn't mean you're weak if you use a grid, just means that you're being careful. And then you've got 4 times the 3 here, which gives you 12. And then you've got the y times the y, which gives you y squared, so 12y squared. And then we've got negative 3 times 3y, which is negative 9y. So that would be the answer. Now you're going to use the equivalent sign here. That's going to be 12y squared minus 9y. And a really good thing to do is, when you're revising, this is like a revision tip, is to work backwards to the question later on. So come back to it and just think, right, okay, if I had 12y squared minus 9y and I wanted to factorise it, what would I do? It would be the opposite of expanding it. So try and use that technique when you're revising. So for this one, we'll finish this off reasonably quickly. We've got t plus 2 here. You don't have to write the plus sign. And t plus 4. And we're just going to multiply those out. So we have a t squared. We've got an 8 here. And then we've got a 4t and a 2t, which in total makes 6t. So there's no rule saying you can't write it in that order, but generally you write the highest power first, then the next highest power, and the next highest power. And you're probably saying, what do you mean highest power? Well, it is 8t to the naught after all, and this really is 6t to the power 1. So I know what you'd write. You'd write t squared plus 6t plus 8, but I just want you to see the pattern here of the descending powers, 2, then 1, and then 0. So that's quite a nice question. So in this question 8, Sandra has a piece of string 153 centimetres long. She cuts the string into 3 lengths in the ratio of 4 to 2 to 3. So the first thing to think about is, how many parts is this altogether? Well, we've got 4 and 2 and 3 makes 9 parts. And the piece of string is 153 centimetres long. So the best thing to do would be to do 153 divided by 9. You can do that on the calculator. One thing to notice is if you made it a fraction, then if you added the digits of 1 and 5 and 3 up, you'd get 9, which means that it's in the 3 times table, so 3 will go into it. So that's going to be 3 times 51 over 3 times 3. 3's cancel, and then 51 divided by 3. Well, if you play darts, treble 17 is 51, so the answer would be 17 for each part. Okay, so in this situation we have 4 parts here, so 4 17s you can do on your calculator, that's 68. 2 17s are 34, and 3 17s are 51. So think about it. If you added 68, 34 and 51 up, you would get 153. So therefore we've split the 153 centimetre long piece of string in that particular ratio. And that's a good technique. You add all the ratios up, get the total number of parts, divide what you have by those parts, and then you just dish them out according to the ratio. And then you can check that they add up. In this case they definitely do. So you just put your final answer here of 68 centimetres, 34 centimetres and 51 centimetres. This question we want to be able to draw a frequency polygon, and I've said in a previous video before that polygon just means many points, and what we're trying to do is with a frequency polygon is show the frequency versus the number of emails sent in this situation. So one way of looking at a frequency polygon is to imagine you've got a bar chart. So if we were just to draw this bar chart like so, and next one 10 and 20 is 17. So let's have a look. 15, 16, 17. I'll do this reasonably quickly. And the next one is 14. Nine, and then 6. A good way of remembering how to do a frequency polygon is just to join the midpoints of the bar chart. What you don't do is, after you've done the joining up, with a ruler, of course. What you don't do is join this up here, because I think when students see the word polygon, they instantly think that you have to have it joined up to make a polygon as you would normally see. Just think as polygon in a real sense as many points. So we'll get rid of the red line, and your answer should be the blue line. So don't draw the boxes, just imagine that they're there. So that's the first thing to do. Now, the next part of the question says, somebody thinks that at least a quarter of these teachers sent more than 30 emails. So if we look at this class interval here, it says that the number of emails has to be more than 30 but less than or equal to 40, and this class interval is safely above 30 already. So we need to be counting up 9 and 6 in terms of the frequency, and that would give us 15 people out of the 51 sent more than 30 emails. So on your calculator you just need to work out 15 divided by 51, and we can do that now. So 15 divided by 51, and we get, as a decimal, 0.29411 and so on. So if you think about the decimal as a percentage, then that is roughly 29.4% to one decimal place, and that is more than a quarter, because a quarter would be 25% or 0.25. So you've got to answer the question, is Nalini correct? And yes, correct, because we have more than a quarter. Okay, and you've got your workings here to show that. Okay, let's move on. So with this question, we've got to look at the rules here. So it's a locus question, and the photocopier has to be closer to B than it is to A. Now I don't have the specialised equipment here, but I would use a compass. I'll put my sharp point here, and I'll be drawing an arc somewhere around here. Doesn't really matter where. And then do the same for this one here. And then move my sharp point to here, keeping the distance between the pencil and the sharp point the same. And then I'd be doing this arc here and this arc here. And then I'd have my ruler and I'd draw a line through these 2 points. So I'm going to do that freehand, and you'll get the idea of what I'm saying. So that's my idea of saying the halfway point between A and B, and I've used construction lines to show that. And then the second rule is the photocopier has to be less than 8 meters from C. Well, we look at the scale, 2 meters is 1 centimeter, so I'd do 4 centimeters on my compass. I'd have the sharp point here, and I would just basically draw part of a circle, and that would be, you can draw the whole circle if you want, but I'd say it'd be something like this, and then I can carry it all the way around if I want to show the construction lines. And then I've got to say, you've got to read this carefully now. It says, show by shading the region where the photocopier can be put. So it's got to be closer to B than it is A. So it's definitely going to be this part here, I would say, because it's also got to be less than 8 meters from C. So I wouldn't say it can be 8 meters from C, so I'm going to draw a dotted line on here. But I don't need this bit here, that's not counted. So I'll do it in another colour. So it's this bit here, and then that's the dotted line there, and then I'll just shade in all of this part here. So it's more fiddly for me because I don't have the specialised equipment, but you do, and you can give that a good practice. So that will be the answer for that question. So in this question again, we've got quality of written communication, and we've got to work out if one length of ribbon is long enough to go all the way around the cake, you must show your working. Well, the top of the cake is in the shape of a circle, and we've given its diameter of 7 inches, and it says a ribbon is going to be put around the side of the cake. Ribbons are sold in 50 centimetre lengths, and it gives you a conversion here that 1 inch is 2.54 centimetres. So I think what we've really got to work out is then what the circumference is. So the circumference is pi times the diameter. What that means is that this diameter will wrap around the outside once, twice, 3 times and a bit more. Okay, so just think about that. 1 time, 2, 3 and a little bit more. So the diameter times pi will wrap around to form the circumference. So just think of your formula in whichever way helps. You don't have to write it like this, you can write it like this if that is better for you. So what information do we have? Well, we want to find the circumference. Pi we can use on our calculator, and the diameter is 7 inches. So the circumference is 7 pi inches. But the ribbon is sold in the units of centimetres, not inches, so we just have to convert this to centimetres. So we just do 7 pi, and then that's inches, so we must times by 2.54 to make it centimetres. So we can use the calculator for that, and we get 7 times pi times 2.54, and in this instance I get 55.857511738 centimetres. I always write down what's on my calculator display, and then, to be honest, if you've done that, you've basically shown the examiner as much as you can, and then you just have to say, right, okay, to the 1 decimal place we've got 55.9 centimetres, just write 1 dp. So I'm afraid that 50 centimetres, i.e. 1 length of ribbon, is not going to be enough. So let's have a look at this question. It's a bit like a puzzle. You have A, B and C lie in order on a straight line. So if we imagine this straight line here, then we've got A here at 2, 5, and we have B somewhere which is at 4p, and then we have C which is at Q 17. I think one thing to do here is to look at the change in the x coordinates. So here we've got from 2 to 4, so we've got a length here of 2. But from A to C we've gone from 2 to Q, so the distance is going to be Q, i.e. the bigger number, with 2 taken off. So that's going to be this distance from A to C in terms of the x length. So because they're on the same line, then if we know that AC, so going from A to C, is 4 times longer than going from A to B, obviously my diagram's not to scale, the x and the y must be in proportion to that rule as well. Okay, so both x and y have to be in proportion, because if they weren't, then B or C would not lie on the same line as A. Okay, but that's the important thing, they do. Okay, so the gradient is always going to be the same no matter where you are on that line. So I think the first thing I would do is to say that using this rule, the length of A to C in terms of the x values would be Q minus 2, and that would be 4 lots of A to B in terms of the x values. In fact, I'll just write the x parts here. So we've got 4 times 2, and that gives us q minus 2 equals 8, so q equals 10. Well, now we can look at the y values, and we can see that from A to C in terms of the y, we have 17 and 5, so 17 minus 5 is 12. But in terms of B to A, we have P minus the 5. So let's go by this rule again, and let's look at the y component. And so AC, so the y component will be 12, is 4 lots of the A to B, which is P minus 5. So we'd have a situation, I'm going to divide both sides by 4, and then I'm going to add 5, and then I'd have P is 8 and Q is 10. Now that's the question done, but let's just investigate a little further about the gradient here. And you don't have to watch this part. If you don't, you can skip ahead. Let's just check then that if A was 2, 5 and B was 4, well, we said P was 8 and Q we're saying was 10, 17, then the gradient from A to B, well, that's the change in y, so we've got 8 minus, I'll use a different colour, we've got 8 minus 5, or 5 minus 8, over 4 minus 2, or 2 minus 4, depends which way you want to go, but you must go the same way for both. In this case we'll get 3 over 2, so the gradient is 1.5. And if we looked from A to C, so the gradient of A to C, then we would have 17 minus 5, or 5 minus 17. Let's do 5 minus 17, there'll be no harm in it. And then 2 minus 10 for the change in x. And we'd have negative 12 over negative 8. Negative divided by negative is positive, so that gives us 12/8, which is 6/4, which is 3/2 again. And you can do the same between B and C, and you'd get exactly the same. So that does confirm that they lie on the same line for our values of P and Q, just in case we had made a mistake, but you don't want to lose marks. If you've got time left over, best bit of advice I can give you is look at a question in a fresh pair of eyes, a different perspective, and try and pick holes in what you've done. And if you can't find fault in what you've done, then you're more than likely got the right answer. So P is 8 here, and Q is 10. Now, in my experience of 20 years, I find that students really worry about bearings. So let's try and take this question reasonably slowly. It says Martin and Janet are in an orienteering race. Martin runs from checkpoint A, so let's just put A here, let's just get it on the paper first. Checkpoint A to checkpoint B on a bearing of 65 degrees. Well, every time you put down a point, always, and I mean always, draw a north line from it. Because if you want to go from A to B, you've got to follow this bearing, and the bearings always go clockwise as the hands on a clock would turn. Okay, that's kind of counterintuitive to how angles work. As you go higher up to like higher levels at GCSE, well, at AS and A2, angles turn anti-clockwise from 0. But in old-fashioned, and I'm telling you, old-fashioned bearings go clockwise. So we want to do an angle of 65 degrees. I'm afraid that my computer's not clever enough to have a protractor, so I'm going to guess what 65 degrees is. but you definitely wouldn't do that in the exam. You'd put your protractor down here. And so we're going to say that this is 65 degrees. Now, it says here that Janet is going to run from checkpoint B to A. Now, you don't know where B is yet, okay? You know it's on this bearing, and you can write 65 degrees here, okay? And look, you've turned clockwise. So B is on this dotted line somewhere. But let's just see what it says about Janet. Janet is going to run from checkpoint B to checkpoint A. And it says work out the bearing of A from B. Which is actually not too bad a question then, because I think that thing that's going to worry students in this question is you don't know where to put B. It doesn't say how far from A, it just says on the bearing. So we can just put B anywhere for now and just say, okay, there it is. Remember my advice? I said put a north line in. And then if Janet is going from B to A, you know, who cares how far away that is in terms of a distance? It's the bearing that they're asking for this time. You just need to make sure that you start turning from the north line until you get on the same line that A is on. Okay, so that's really the angle we've got to find, and bearings have got to be 3 figures, okay, with a degree sign. So we should be able to use our maths knowledge to work that out, and it's the north lines that really help us, because guess what? They are parallel to each other. So you can use your ideas of parallel lines, and you can see here you've got a nice Z angle. You're not allowed to say that in the exam anymore, but it's an alternate situation, so you know that this angle here is going to be 65 degrees as well. And you definitely know this part, that's 180. So you've got 180 and 65, which is 245 degrees, is the bearing that Janet will run on from B to A. So you just put the north lines in, you always go clockwise, and if it helps you, just make these north lines really long then, because then you can just use the ideas of parallel lines, okay? Normally in questions you see them this way, don't you? So bearings can be really good. It's just about angles really. Okay, so nothing to worry about. Now for this type of question, when you want to estimate the mean here, you know that in the first class interval 10 people ran a time between 60 and 90. So time is the continuous measurement, so even though it couldn't be 60, as good as 60 is fine. 60.0001 seconds is, you know, possible, even though it would never be measured that way. So we just assume 60 and 90 is the first class interval. Now when we're looking at the mean, because we don't know how the times varied, we just know there was 10 times in that class interval. With the mean, when we're trying to estimate it, we always assume the midpoint. Now I'm drawing a graph like this, which shows the normal distribution of some data. So if you had heights, for example, in the United Kingdom, then heights would basically, the most of them would peak around this area here in terms of the frequency, and then you'd get some very, very tall people at the top and some, you know, smaller people at the bottom here. So we would assume now, using the idea of central tendency, i.e. things gather around the middle, that if we had 90 here and 60 here, and you've got your calculator, there's really nothing to worry about, we can find the halfway point by adding the two endpoints together and halving. So 150 over 2 would give us 75, and there's no harm in just writing MP here for midpoint. 90 and 120 is 210, halved is 105. 120 and 150 is 270, halved is 135, and 150 and 180 is 330, and if I halve that I'll have 165, and then lastly here 195. So just to get the principle firmly in your head, we're assuming now that 10 of those times were centered around the midpoint. So we have 10 lots of 75, which is 750. We have then 14 lots of 105, which I can do in my calculator. So we've got 14 times 105, which is 1,470. Then we've got 9 at 135, which is 1,215, plus 5 165s, which is 825, plus 2 195s, which is 390. If we add all of those parts up, maybe it's best to kind of stop there for a moment and just think, right, so you've understood that that's like having all the times lined up, every single person's time. Okay? But a common mistake is to just divide by 1, 2, 3, 4, 5 because there's 5 classes. No, there's 40 runners here. Okay, it's really important. And that's what these would add up to. So you've got to divide it by 40 to get the mean. So let's do that calculation. So 750 plus 1470 plus 1215 plus 825 plus 390. I would not divide by 40 just yet. I'd write down what I thought the calculator told me, just in case I made a mistake. Then the examiner could see exactly what you're doing. And then I'm going to divide by 40 now. And I get 116.25, and that's going to be in minutes. And that would be my answer, okay? And that is only an estimate because we didn't actually know in this situation what the times were. The nice thing about this is if you have enough frequencies, then you can have good estimates for means without actually having to know everyone's actual time. You've probably done this kind of exercise in class before. Okay, so that's the answer for that question. In this question, you've got to work out the value of 25 to the power negative 3. Well, as a slight example here, if you had 5 to the 3, that's 5 times 5 times 5, which is 125. 5 squared is 5 times 5, which is 25. 5 to the power 1 would be 5. 5 to the power 0, well, each of these are becoming 5 times less. You're dividing by 5 consistently here, so you're having 1 here. 5 to the power minus 1 then would be 1/5, because it's 5 times less. 5 to the minus 2 would be 1/25, and so on. So when we're looking at 25 to the power negative 3, and it's just dawned on me this is a calculator paper, but let's just pretend it isn't, then if we had 25 to the 0, that would be 1, so 25 to the power minus 1 would be 1/25, and so on. So by the time we get to 25 to the power minus 3, we've got 1 over 25 cubed. Now, I should get my calculator, but I can't be bothered to do that right now. So 25 times 25 times 25, well, that's going to be 5 times 5 times 5 times 5 times 5 times 5. And 5 cubed is 125, and 5 cubed is 125. And if you want to square a number ending in 5, i.e. 125 squared, it will end in 25, and then you take the number here, 12 for example, you raise 12 by 1 to get 13, and then you times 12 by 13 and you get 156. So it's going to be 1 over 15,625. So that could be the answer you put as a fraction. By the way, if you had to square 75, then if it ends in a 5, then if you square it, it ends in 25. You take the number 7, increase it by 1, which gives you 8, and you just do 8 times 7 is 56. So the answer would be 5,625. And it works with all numbers ending in 5. So I just noticed one thing that's not very clear. So that's 8. So work out the value of 350 to the power 3. Well, that's going to be 350 times 350 times 350, which is 35 times 10 times 35 times 10 times 35 times 10. Well, the 10 times the 10 is 100, times the 10 is in the thousands. And then I've got 35 times 35. Well, we can do that because any number squared ends in 25. And we take 3, increase it by 1, so that's 3 fours are 12. So we've got 1,225,000, but then we've got to times that by 35. So let's have a look at what that will be. There's a reason why I'm doing it without a calculator first, and you'll see that if you're patient. So if we do 35 times 1,225,000, then I'm not particularly worried about how big that number is. I'm going to do 35 times 1,225. So that's not too bad. And then the units, then the tens, hundreds, and so on. So I've got 42,875, but of course I missed out the magnitude of timesing by that 1,000. So there's the actual answer as an ordinary number. Now, coming back to both parts of the question, A and B now, if you did part A with the calculator, then you would have an answer on the calculator here of 0.0000064. Now these look very different, obviously. That's the fraction, and this is the decimal equivalent. Now, being able to do it without a calculator is quite important, I think, because just plugging it into the calculator, you kind of lose what's happening in the question. But like I said, this is a calculator question. That's absolutely fine, as long as you realise that this is exactly the same as this. In this question here, this is not in standard form. Now, if I was to just plug in 35 times 1,225,000, or better still, 350 to the power of 3, a lot of calculators would give something like this. They'd give 4.2875E7, for example. Well, this E7 is just a way of the calculator saying times 10 to the power 7. Now, if you had that as your answer, then that would get you 2 marks. That's in standard form. But this is in ordinary form. So all standard form is saying is how many powers of 10 are there in the number you've got. And in this case, you can see there's 1 power, 2, 3, 4, 5, 6, 7 powers of 10. So that's why we have 4.2875 times 10 to the 7, because if we had 4.2875 and we times it by 10 7 times, we would have, well, this number would get 10 times bigger, so we would have 42.875, so that's timesing it by 10 once, then we'd times it by 10 twice, 3 times, 4 times, 5 times, 6 times, 7 times, and we'd end up here. So just be aware that standard form is quite tricky, and it's going to be tricky for you if you don't take care and attention with the numbers themselves, i.e. what the question is asking. Try and do it by hand, and then you'll get a sense of how big the number is. If you're just faced with this on your calculator and don't understand it, that tells me quite a lot. It tells me that really you've not really investigated what large numbers are by hand. And I think if you do that, you'll understand standard form real quick. So we're going with 4.2875 times 10 to the 7. Now I think this is a very difficult question. It says liquid A has a density. Now let's just write that down for starters. So we've got density is of liquid A is 0.7 grams over 1 centimetre cubes. Now I've written it like that because that's what the dimensions, and I'll write this word down again, I've done it in a previous video. The dimensions tell us what we're talking about here, because grams is the mass, and this 1 centimetre cube here, which you can almost see if I draw one for you, tells you that in 1 centimetre cube you've got 0.7 grams, because it's 0.7 grams per 1 centimetre cube, and that centimetre cube is a given volume. It's like a set amount of space, and you've got to pack the liquid or the gas or the solid into that particular space. Okay, and the more you can put into that confined space of 1 centimetre cube, the more dense it would be. Okay, so if you had sawdust, for example, and you try to pack that into a certain space, it doesn't have to be a centimetre cube, but say it was a metre cube, for example, you could pack, you think, quite a lot. But if you were to pour liquid gold into it, then you would find you could put a great deal amount more of liquid gold into a metre cube than you could sawdust, and it would weigh a massive amount more in terms of the gold than it would the sawdust. Okay, so the density is how much mass you can pack into a given volume. So for the density of B, we've got 1.6 grams per 1 centimetre cube. So 140 grams of liquid A and 128 grams of liquid B are mixed to make liquid C. So if we want to look about the density of liquid C, density is the mass of liquid C over the volume of liquid C. So we know that 140 and 128 gives us 268 grams, so we do know that the mass of liquid C is going to be 268 grams. Now, what do you think we have to do next? You see, for me, the question is tricky because it kind of tells you the answer. It's told you there's 140 grams of liquid A, you see. So if you look at the formula, density of A is the mass of A over the volume of A, then if you know the density of liquid A is 0.7 grams per centimetre cube, then you know that you've got 0.7 here is equal to the mass, and it tells you the mass of liquid A is 140 over its volume. So if you times both sides by V and divide both sides by 0.7, or if you don't like that, you can treat this as a fraction and you can turn this left hand side upside down, i.e. find the reciprocal, and do the same to the right hand side, and then times by 140, you'll have the volume of liquid A would be 140 over 0.7, and you can use your calculator for that and it will give you the answer of 200. And don't forget the volume will be 200 centimetre cubes. So that's one thing to look about, because we know to find this volume of liquid C, we've really got to find the combined volumes for A and B. So we can do the volume of B now exactly the same way as we did A. So we can say the density of B is the mass of B over the volume of B, and before you put the values in, you can rearrange the formula if you want. So you can times both sides by VB, so VB dB will equal MB, and then divide both sides by dB. You don't need a formula triangle to help you remember that, you can just use your algebra, that's how you should be doing it. And then put in the numbers. So we've got the mass of B was given, and that was, I believe, 128 grams. And it told you its density at the start of the question, which was 1.6. So the volume is going to be 128 divided by 1.6, and I get 80. And that's 80 centimetre cubes. So we can now get back to our crucial formula here, and we can put in the missing link, because the volume of C is really the volume of A plus the volume of B. Okay, so we had 200 plus the 80, and that was in centimetre cubes. So we've still got our dimensions, look, we've got grams per centimetre cube, but we actually have now 268 grams per 280 centimetre cubes. So we can work out our density now as 268 divided by 280, and here's my answer, and I'm going to write this in a bracket. So 0.9571428. That's what my calculator says. And does it want it to any significant figures? No. So what I would do is I'd probably look at the question, and I would say that as the grams were given to 3 significant figures, I'd give my answer to 3 significant figures here, and so I would say 0.957 grams per centimetre cube, and I'd write 3SF here. So in this question we've got a straight line N that's shown, and we've got to find an equation of the line that's perpendicular to line N that passes through the point 0, 1. So I think the first thing that we should do is probably find out a bit about N, and the first thing we can do is choose a point on the line that's a nice point that we know, and so we know that's 1 here and 1 here. And so if we go along, we know this is going along 1 unit, and then if we go up here, we've gone up 3 units. So if this is the change, and I'm using delta here, the Greek letter of the alphabet, delta, for the change, here this is my delta y, here this is my delta x. So what I'm saying is, if I go along 1 unit, I'm going up 3. So if I went along, say from here, 2 units, I'd expect to go up 6. So 1, 2, 3, 4, 5, 6, and so on. So basically the times table that I'm going up in is 3's. So the gradient is the change in y over the change in x, 3 divided by 1, or the times table I'm going up in is the 3 times table. So you can always go on a point on the line here. You can go back, for example, 3 units here, and you'd have to go down by 3 times as much. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and so on. So you don't always have to go forward. So we know that the gradient of line n is 3. So I don't know if you know much about gradients when you've got lines that are perpendicular, but there's a special rule, and that is if you have 2 lines, say A and B, and you've got the gradient of A and you have the gradient of B, if you multiply those 2 gradients together, they should always be -1. That's if one line is perpendicular to the other. So if you have a line and you want one that's at right angles, if you know the gradient of one of the lines and you multiply it by the gradient of the one that's perpendicular to it, you would always get -1. So we know the gradient of n, and that is 3, so we've got to find a number that when times by 3 is -1. So in some ways you can use algebra, so you could divide both sides by 3 here, and you'd have x equals -1/3. And then just to show you how it works, if you do 3 times -1/3, well, what do you get? Well, the 3's cancel and you're left with -1. So that's the property for lines to be perpendicular to each other. So we know that the equation of a line that's perpendicular to n must have a gradient of -1/3. So that's the first fact we want to keep hold of. Okay, so the gradient of our new line, and we can call that just m in this case, is -1/3. But we also know that it has to pass through this point 0, 1. So there's 2 ways of looking at this. One way is you know the equation of a straight line is y equals mx plus c, where c is the intercept on the y-axis and m is the gradient in question. So we know that at least, so we can say y is going to be -1/3 of x plus c, and if you want you can write that like this, which is -x/3 plus c. They mean exactly the same things. And then the nice way about knowing this is if you know that there's a point that it goes through, 0, 1, this means that x is 0 when y is 1. And you can substitute these values into here. And you know -0 is 0 divided by 3 is still 0, so we end up with c is 1. So we then say to ourselves, well, c is 1, and so our line that we want is going to have the form of mx, so -1/3 x plus c, which is 1. And you can write that like this, which is exactly the same. An alternative way of doing this is to use the equation y minus y1 is mx minus x1. I've got a video on this, so I can put a link up at some point, but using this equation all you have to know is m, which we have, and then a general point that the line goes through with its y and x parts, and we're lucky enough that we were given that here in the question. So again, we just say x1 is 0, y1 is 1, and we just put the numbers in just like we did before. So we've got y minus 1 equals -1/3 of x minus 0. So we'd have y minus 1 is -1/3 x, add 1 to both sides, and we'd have y equals minus 1/3 x plus 1, or y is minus x over 3 plus 1. Now there's no hard and fast rules here on how you must give your line. You can give it in this form. When you get to A level, generally they ask you in this form, ax plus by plus c equals 0, and that's okay. So if we took this one here, if we multiplied both sides by 3, we'd end up with 3y equals minus x plus 3. We could then add x to both sides, take away 3 from both sides, move the x's at the front, and that would be our answer, where a was 1 in this case, b was 3, and c was negative 3. So x plus 3y minus 3 is exactly the same as this. So if you're doing the higher paper, keep an eye on that, because that's where straight lines can generally head. They ask you to write them in different forms. So that's a thorough explanation of that question anyway. Now with this question, you're given values, the least values, the greatest, lowest, quartile, upper quartile, and the median. So when you've got lower quartile, upper quartile, and median, you really should be thinking cumulative frequency graphs or box plots. And it says what type of diagram could you draw to represent the information for each month. And as you do have the lower quartile, the median, and the upper quartile value, I suggest that I would say box plot here. However, you know also that when you've got a cumulative frequency curve, an ogive, that you can find the median here, the lower quartile and the upper quartile, and so you could use cumulative frequency, that's fine, but I'd go for box plot. Now, we've got equality of written communication here, and it says compare the distribution of the number of cars recorded in July with the distribution of the number of cars recorded in December. Now, almost all the time when you're comparing, usually when you've got two box plots, I'll show you a little example. Sometimes you've got a box plot like so, and then another one, and you have to compare them. Then you generally compare the 50% of the data, because this is the first 25%, and that's the 75% mark. This is the 100% mark. This is 0%. So you usually compare the spread, it's called. So it's the not quite the range as you know it when you're a youngster, when you're doing range for the first time, it's highest minus lowest. It's not so much that distribution, you're just looking more in at 50% of the data. So I would say the interquartile range, which is the inter means between, so between the lower and upper quartile. So the interquartile range, and we can use the word spread, is, well, let's have a look. The interquartile range for December, so if we just do this for December and July, and we can call that the spread. So we'd say in December it's 150 minus 115, which is 35, and for July it's 60. So you could say that the interquartile range, or the spread, is lower in December. That's the first thing you can say. Now, something tells me in the back of my mind you have to use the figures. Just writing the sentence is not enough. So I would say, you know, the December spread is 35 versus July, which was 60. So I would definitely put the figures in. Okay, so remember that, and then also I would look at the median and compare those. I know it's in the grid already, but just say the median number of cars parked at 12 noon in the car park was lower in July, i.e. December 130 versus July 95. Now, I'm sure people are saying, why is he spending so much time on writing this? Well, in my experience, you will not get both marks unless you relate your writing to the context. And the word context is nothing to worry about. It just means the context here is a car park and the number of cars parked in it. So you can't just say median's lower in July, spread is lower in December. For at least one of those occasions, you need to mention about the cars in the car park and the context. Okay? If you don't want to do it, then leave that out and you'll realise you won't get that mark. Okay, you'll only get one. So, as dull as it may be to write the whole thing out, it is what you really should do, because someone reading it might not understand what you're talking about. So, let's move on. In this question, we've really got to calculate the length of CE. So this whole length here. And really we've just got to work around the triangles that we have and hopefully get the information we need. So first of all, let's fill in some information on the diagram that could be useful. Well, this is 30 degrees because that's a right angle. This is a right angle here, as is this. And the nice thing that we have here in triangle ABC, so in triangle ABC, we have a situation where if we use this as our angle, we have the opposite here, which is 12, and we can find the adjacent or the hypotenuse. I think what I'm going to do is I'm going to find the adjacent first. So however you do your trigonometry, I've got videos on the unit circle and what I think sine and cosine is all about, but I'm happy to go with SOHCAHTOA for now, which seems to be universally accepted. So if we've got the angle of 60 and we're looking at the opposite and adjacent, then we'll have tan 60 is 12 over A. So if we times both sides by A, that would give A tan 60 equals 12, and then divide both sides by tan 60, so we get 12 over tan 60. Now I know the tan of 60 is root 3, you've got your calculator, so I'll rationalise both sides. At this point you may have already got a decimal, that's absolutely fine. So, but I'm going to call mine 12 root 3 over 3, or 4 root 3 in this case. So let me just get this here, there we go. So I'm going to call that 4 root 3. So you may have a decimal at this point. So if that length there is 4 root 3, then this length here is also 4 root 3. Now, we know already that this length from here to here, has got to be the same as this length from here to here. So we know we've already got 12 centimetres in the bag. That's from there to there. So we've really just got to find this part here. So, because this is a right angle here, and I've got this angle of 30, then this angle here, 90 and 30 is 120, that means this angle's got to be 60 degrees. So we can find ED, because if we just look at this triangle here, AED, then basically we've got the angle, we've got the opposite, and we want the adjacent. The hypotenuse is always opposite the right angle. So what we can do here is, and I'll just keep my workings here because it might just help you see what's going on. In triangle EDA, we have tan of 60 again is opposite, which is 4 root 3, or the decimal that you've got, over the adjacent. So times both sides by A again. So A tan 60 is 4 root 3, and then A will be 4 root 3 over tan 60, which is root 3. So you just get 4 here. So we now know that the length of CE, so therefore CE is going to be 12 plus the 4, which is 16 centimetres. So the only thing in this question which is a bit worrying is perhaps that you may have thought of trying to find this length here first. You could have, but then you'd have had to have looked in triangle AEC and then maybe been able to find this length next. But the quickest route was basically trying to work up to the length here, which was the difficult one to find. So the sooner you could work up to that length, i.e. in the top triangle here, the better. So with these trigonometry questions, take your time on them. Sometimes it's a good idea to draw the triangle that you're working on each time. So in the first instance I was working on triangle ABC, and then just draw the diagram separate from the one that you've got. So let's move on. In this question there's a couple of methods you can use. Method 1, in this particular question, I'm not saying there's like 2 or 3 methods for this type of question, I'm just saying that for this expression, method 1 would be to use maybe a squared minus b squared, which some of you are thinking, well, that's a plus b times a minus b, and then you can just say, well, a in this case would be n plus 3 plus b, which is n minus 3, multiplied by a, which is n plus 3, minus b, which is n minus 3, and then just simplify. So you'll have 2n, because the 3's cancel, multiplied by, be very careful here, n minus n is 0, and 3 minus minus 3 is 3, add 3, which is 6, which gives you 12n. Now some of you could say to yourself, well, 12's even, so if I times it by any number I'm going to get an even, and in some ways you could be correct, but I'm telling you now, you really should get this magic number here, the first even number here, 2, and make that appear in your workings. Because then, no matter what n is, it will be times by 6, but then at the very end it will be doubled, which will always make it even. So if we chose an odd number, say n is 3, when it's times by 6, we're okay anyway. We happen to get 18, but when we double it, we'll end up with 36, which is definitely even. So what it's really saying is n can be any number, and when we do 6n of it and then multiply it by 2, we're always going to get an even. So all we have to say is, because we have 2 times 6n, we will always have a multiple of 2 which is even in all cases. Something along that nature. Just think of this number 2 and how you can best incorporate that into your conclusion. There's not just one way of doing it, there's many ways of doing it. So good luck with finding your way. Method 2 in here would be to just expand the brackets. So we're starting with n plus 3 squared minus n minus 3 squared. So we'd have n squared plus 6n plus 9 minus, and be very careful here, n squared minus 6n plus 9. And you can use a grid if you're not sure. If you're not sure, just use a grid and you'll realise why that's 9 and why you get minus 3n minus another 3n and so on, giving you n squared minus 6n plus 9. But when you take these away, you've got n minus n squared, which is 0. You've got 6n minus 6n, which is 12n, and then you've got the 9 minus the 9, which is 0. So you're left with 12n the same, which I would say is 2 lots of something, and then use your similar conclusion. In this question, we've got 2 rectangular flower beds. The dimensions of the larger rectangle will be 3 times the dimensions of the smaller one. So let's just imagine we had a smaller one here, and let's just say it measured 2 by 3. It doesn't really matter what these measurements are, okay? I just want to do an example. Then, yeah, that was 180 kilograms of soil. But if we wanted to times the dimensions up by 3, then you'd have 2, 4, 6 here, because that would be times by 3, and then you'd have 3, 6, 9 for this dimension of the larger one. So if you kind of complete all of that, you'll see now quite quickly that if it was 180 kilograms of soil to do the 2 by 3, and the 2 and 3 I just made up, it could be x and y, and you can just multiply them up like that instead. Maybe that would have been a better idea. Then you can see you've got 1, 2, 3, 4, 5, 6, 7, 8, 9 times as much. So if you needed 180 kilograms for the smaller one, you're going to need 9 times as much. So 180 times by 9 is going to be 1,620 kilograms. So I think generally I probably should have explained this way. So if I had a rectangle measuring x by y, if I made it 3 times bigger, I'd have x, another x, another x. So that would be 3x, and then a y, and another y. So that would be 3y. Don't forget it's rectangular, so y is going to be greater than x. Just make it look a bit greater. So if that was 180 kilograms here, then you can see there's 9 of those. So that's one way. Another way is to say that if the length scale factor is 3, from the smaller to the larger, then the area one is going to be 3 in both directions, so it's 3 squared, and the volume one would be 3 cubed. It said here that there's the same depth of soil in each flower bed, so it's saying, hey, don't look at the depth, just look at the area. So we're going to just say 3 squared, which is 9 times as much. But either or, you've got to do 180 times 9, either diagrammatically or using this situation here. In this particular question, Claire is making a loaf of bread, and a loaf of bread loses 12% of its weight when it is baked. She wants the loaf of bread to weigh 1.1 kilograms. So we want the final outcome to be 1.1. And then if we have our loaf of bread here, we know that it loses 12% of its weight. So if you think about 100% as being the whole loaf, we know that if 12% of it is gone, there's only 88% of it left. So basically, 88% of the bread which is left will weigh 1.1 kilograms. Now, a nice way of writing this part, because I'm forming an equation here, is to say 88% is 0.88, and of is times, and the bread, well, I'm not going to draw another loaf, I'm going to call it, say, y is 1.1, and if you divide both sides by 0.88, you'll get 1.1 over 0.88. Now if you do that on the calculator, this will be the interesting part, because you'll have 1.1 divided by 0.88, which is 5/4 or 1.25, and that'd be 1.25 kilograms, which is the answer. Now I just want to give a quick example of how to form the left-hand side with these types of questions. So we don't have to talk about the bread now, we can just talk about something in general. If we wanted to have an object, call it y, and we wanted to keep its value the same, we would just keep timesing it by 1. So we'd end up 1 times y is just y, and that 1 is like having 100% of its value intact. If it lost 50% of its value, you would have 0.5y, i.e. half of it left. If it lost 75% of its value, there would be 0.25 of it left. So again, if you're losing 12% of its value, you've got 0.88 of it left. And that's what students find a little bit difficult. So say if you lost 1% of your value, what would you have left, do you think? Well, 0.99 of y. But if you lost 0.5%, what do you think it would be? Well, it would be 0.995y. And this is why it's worth doing a few more minutes on this, because this is what a lot of students find quite difficult. So if you're not happy with what I've just said, if you lose 0.5% of something, then you've got 99.5% left. And if you've got your calculator, percent means just divide by 100, i.e. per 100. And if you did that on the calculator, you'd end up with 0.995. When you've got situations where something is gaining in value, and say something appreciates in value by 10%, then instead of having y, the object you start with, you're timesing it by 1.1. Why? Well, if you're gaining 10%, you have 110% left, i.e. it's appreciated by 10%. But you know that 110% is 110 divided by 100, because it's 110 per 100%, and that would give you the 1.1. So if you gained, say, 3.75%, and you wanted to do that all in one go, what would you times y by? Well, it would be 1.0375. So revise these. They're not as bad as they seem, but you kind of have to know how to manipulate percentages, especially when things are appreciating or depreciating in value, or in weight in terms of the bread that is in this question. So the answer for this question we've already given was 1.25 kilograms. And if you're still not sure on that, then you can just check it by just taking 12% off the 1.25 and you'd end up with 1.1. I think another reasonably popular way of doing this question is to say, for example, 88% of the loaf is 1.1 kilograms that we had at the end, and you've got to work your way back to 100. So you've got a calculator, so if you divided both sides of this by 88, and think of this as being like the proportionality between them. So the 88% is 1.1, so we're doing some kind of proportion calculation here. So we're dividing both sides here by 88. You'd end up with 1% would be 1.1 over 88. And I'll do that quickly. That'll be 1.1 divided by 88. And that will be 0.0125, and then once you've got the 1, you can always just times both sides by 100, and then you've got your 100% is going to be 100 times this value here, which will give you 1.25. So there are plenty of other options on doing this, but there's a couple of ways for you. I have to say that when you do some very complicated percentage questions, it's sometimes quicker to use the multiplier method, i.e. here, rather than this method here. But like I said, it's completely up to you as long as you get the marks. Now for this question, you've got to work out the area of this parallelogram. I just want to say a couple of things about the area of a parallelogram. If you imagine that these are infinitely long parallel lines, then if you're good at triangles, and I think you're okay with the area of a triangle is base times perpendicular height. So if I just create a triangle here, for example, this would be its base given, which is 7. If we could find out its perpendicular height, i.e. the distance between these parallel lines, h, that's uniform, so that's the same no matter where we are. It's always going to be that height. That's the perpendicular height. And then if you've got one of the triangles, you see, which is base times perpendicular height halved, then you can see that if I double the amount, I'll get the area of the parallelogram. And if I double this, I just get base times height. And I'm talking here perpendicular height. Okay, so that is the formula for the area of a parallelogram. I wouldn't say it's particularly a formula, it's just a common sense way of finding it. So you find the area of one of the triangles and you just double. Okay, so in this particular question, let's just go back here now and get rid of this here. So we know that we're looking for the area of this parallelogram, and I should just get back, there we go, I'll leave that as that. We just now need to find one thing only, and that is this length here. Okay, don't forget it's the same between this parallel line and this one, it's always going to be the same. I'm going to call this length x. Now if you think about it, that's the height or the distance between the parallel lines at any point, as long as it's the perpendicular distance between the parallel lines. Okay, so that's going to be the same distance as well, x. Now once we have that, all we've got to do is multiply 7 by x and then we're done. That's going to be the area of the parallelogram. So in this right angle triangle here, which I'll enlarge for you, we have got an angle, so we've got the opposite, we have got the hypotenuse, so we're going to use the sine, so we're going to say sine 40 equals opposite over hypotenuse, so that means if you times both sides by 5, that means 5 sine 40 equals x. I'm not going to put that in my calculator just now. I haven't really got any interest on what that is as a decimal just yet. And then I'm going to come back to my question and say, therefore the area is going to be the base, which is 7 times by 5 sine 40, and then now I'm going to use my calculator. So I'm going to have 7 times 5, which is 35, times the sine of 40. Make sure your calculator is in degrees, and I get 22.4975634 centimetre squares. Then I look carefully to see what it wants. It wants it to one decimal place, so I'm going to have 22.5 centimetre squares, and I'm going to write 1 dp just there. Now, one thing that can worry some students is thinking, well, I wanted to use this triangle here. It's absolutely fine where you see your triangle, but don't lose sight of the crucial fact here is you need to find the perpendicular height of that parallelogram, okay? And then you just need to times it by its base, that's it. So however you find your x is completely up to you. You could have used this triangle here, that's absolutely fine. You could have used this angle here as being 50 instead of the 40, and then you would have used cos of 50 instead of sine of 40, for example. But like I said, just stick with what you have to get and get that as quickly as you can. In this question we've got, he travelled 235 miles correct to the nearest 5. So I've done an upper and lower bounds question in a previous paper, I believe, and I always say, well, you take the 235, it's to the nearest 5, so you split the 5 in half, and if you add 2.5 to 235, you get 237.5 miles, and if you take 2.5 away, you'll get 232.5 miles, and that will be the lower bound and that will be the upper bound. If you look at the journey time, 200 minutes correct to the nearest 5 minutes, again you take the 200, you take what it's rounded to the nearest 5, and you take 5, so that will be 197.5 minutes, and you add 2.5, which would give you 202.5 minutes. And I'll write underneath lower bound, upper bound, lower bound, upper bound. So what you've got to look at in this situation is calculate the lower bound for the average speed. Well, speed is given in miles per hour, so we've got the units here is a distance over a time, so speed is distance per time, and we want the lower bound, so I use my thing that I've talked about before, which is cakes and people. If you want the lowest amount of cake per person, then you want the number of cakes on the table to be its lowest, but you want the number of people to be the greatest, and then everyone gets less. So I would say cakes lowest, so the distance part has got to be the lowest, so we'll choose 232.5. and the time part has got to be the greatest, and that's going to be 202.5. Now you've got a calculator here. I think what you can do is double out of trouble if you've got a decimal, especially ending in 0.5, and so you'll get 465 over 405. Divide top and bottom by 5 and you'll get 93 over 81. And then if you divide top and bottom by 3 again, you'll get 31 over 27. However, this 31 over 27 is in a different kind of unit here. We have 31 miles in 27 minutes. Now can you see what the problem is here? We wanted it in miles per hour. That's what the question asked, and I'll show you here. There we go, miles per hour. But what we have is miles per minute. So what do you think you're going to do to change this into the correct units? Well, one way of helping you think about this is if you've got 31/27 per 1 minute, then that's how much in the first minute, and then that's how much in the second minute, and then the third minute is all of those three added together, and so on, the fourth minute. Can you see you're going to have 60 of those to make up the hour? So you've got 31/27 times 60. You've got a calculator. I like to do this without to help you with your number skills. And then we've got 31 times 20, that is, well, 2 31s is 62, so that's 620 over 9. And then I'll use my calculator here. 620 divided by 9, and that gives me 68.8 recurring miles per hour. But it wants the answer correct to, I believe, 3 significant figures here. So all we have to do is take our working, and we can just say, okay, 68.8 recurring, 3 significant figures is going to end up with 68.9 miles per hour, and we just write 3SF. So let's move on to the next question. With this question I shall start with the most popular way, and that is using the formula, which is found on the formula sheet at the front of the paper. So if we write out the initial equation, so this is method 1, and we then have A is 3, B is 4, and C is negative 12. I guess that is there to try and trick you in some ways. Just think of it as being plus minus 12, and then you'll get this bit correct. And then we just plug it into the formula. So we'd have x is minus 4 plus or minus the square root of b squared. Anything squared is positive. Minus, here comes the next tricky part for some people, 4 times a times c. So be very careful here. And the first thing I always do is if I see 2 minuses here, then I just make that a plus really quick before I forget. Okay, so you made those 2 minuses pluses, because 2 minuses together when multiplied is plus. And then we end up with our denominator of 2a, which is 6. Then all we have to do with this method is 16 plus 4 3s are 12 times 12. You've got your calculator, of course, so happy to use that to do some of these stages. But the numbers are not too bad. 16 plus 144 all over 6. So you'd get minus 4 plus or minus 160 over 6. So you'll end up with minus 4 plus or minus. Now square root of 160, well, it's third. I know this is decimal places. I'm just going to go all the way through it without using a calculator first, just to show you a couple of things on the way. One of them being thirds. If I wanted 160, what's the highest square number? Well, if you write your square numbers, then straight away you can see that's 16 times 10. So you've got the square root of 16 times the square root of 10, which is 4 root 10 over 6. And then you can halve the numerator and halve the denominator. And then from this, you'll be able to get the line of symmetry and then how far from the line of symmetry in either direction, plus or minus, the solution points. So I think if I was doing this in the exam and I wanted to use my calculator, I would probably start using it at this point here, and I would just put in negative 4 plus the square root of 160 and then divide it all by 6. So I'll probably put a bracket in here. So I'll say bracket negative button 4 plus root 160 bracket all divided by 6. And then I'll do exactly the same and then change this to a minus because I wanted the minus. Put your bracket in and then go like that. So your solutions would be 1.44 to 2 decimal places, or negative 2.77 to 2 decimal places. Another method which some people can employ is to use completing the square. So you can have 3x squared plus 4x minus 12, add 12 to both sides, divide everything by 3, complete the square here, change the 4 into ninths, and then you can just add 4 ninths to both sides, square root both sides, don't forget the plus or minus, square root of 40 over 3, and then you've got x is minus 2/3 plus or minus root 40 over 3, which gives you minus 2 plus or minus root 40 over 3. Now, if you were to go and compare what we had here with what we've got here, then you should be able to notice that root 40, just here, in third form, is 4 times 10, the square root of 4 times the square root of 10, which is 2 root 10, which is exactly what I had here. So completing the square in some ways, if you just had to give your answer, and usually at A level, you'd give your answer in this form, kind of gets there a little faster than using the formula. And then don't forget, if you're using this second method, you just put into your calculator minus 2 plus 2 root 10 brackets, divide by 3, do it with a plus sign here, and then change it and do the minus afterwards, and you get exactly the same answers. Okay, let's move on. For this question, we've got to fill in the table given the histogram. Now, the nice thing about a histogram is that if we look at the area of one of the bars, that's going to be the frequency. Okay, always the case. So in this situation, we had 10 multiplied by a height of 0.4 in terms of the frequency density, and that gave us 4. Another thing to notice here is also that if this is 4, then that means each one of these boxes represents one person. So a quick way of doing it for some of these is to say, what, you got 1, 2, 3, 4, 5, 6, 7, 8 for this one, and that's between 20 and 25. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 here for this last one, because it went from 35 to 50 and so on. 4, 5, 6, 7, 8, 9, 10. And then this one, 1, 2, 3, 4, 5, 6, 7, 8. And then these two make a whole box, that's 9. Alternatively, you could have just read off the scale. So here's an easy one, for example. So for the 20 to 25, you could have said it's got a width as 5 and a height of 1.6, and then the area you could have said is the frequency, and you could have done 5 times 1.6, which would have given you the 8. So it's up to you how you do it. If you can work out what one of these means in terms of people or the frequency, then you're on to a winner, really. So let's have a look at what the question is asking us next. And now we've got to work out the proportion of people in the sample who have a salary greater than £40,000. So we'll count here. So we've got 4 so far, and then 13, 21, 31, so 43. So it's going to be something out of 43. And if we look at the histogram here, let's have a look. Then when we get to the 40 mark here, this is 40,000 and above, we've got 1, 2, 3, 4, 5, 6, 7, 8. I'll just mark those there so you can see which ones I'm counting. So we have 8 out of 43 would be my fraction, i.e. the proportion of the people in the sample who have a salary greater than 40,000. The next part asks for find an estimate for the median salary. Well, now you know there's 43 people. If you line them all up in order of salary, from smallest to greatest, just like the histogram's already done for us, then we'd know we'd get 21 people one side, 21 people the other, and there'd be one person in the middle, and that would be the 22nd person. So all we've got to do is look in the table, which we have here, where I already did the numbers, so I'll just line those up. And by the time we got to here, we'd done the 21st. So the 22nd will be the first person in the histogram here. So let's get some of this other stuff out of the way. And let's just get to the 22nd person. So just counting again, 4, 13, 21. So the 21st person has the first 3 bars taken care of. So we just need one more person's worth, and that's going to be these 5 strips of 5 little squares, because that's going to make one extra person. Then all you do is you just read that off on the scale, and you're not at 25, you're now at 26. So if you're at 26, it's in thousands. So the answer I'd put here is £26,000. So sorry if that was a bit of a mess, and I'm sure you'll do it a lot neater in your exam. So let's go on to the next one. Now in this question, it's vectors, not students' favourites, I have to say, but we've got to represent the vector OC in terms of A and B, and we're given a few bits of information to go on. Ratio, you've got to be very careful. So it means that if AB has 2 parts, then BC has 5 parts. So how many parts have we got altogether? Well, 7 parts, so that must take us from A all the way to C. And AB has 2 of them. So if you think about it, we've got 2/7 here and 5/7. So AB will have 2/7 and BC will have 5 of those 7s. So just try and think of it that way. So let's start the question and we'll keep that ratio in mind. So we know what OA is and we know what OB is, and we want to go from O to C. So if we want to go from O to C, then the journey you can take is you can go from O to A and then A to C. So I would say O to C is the same as going O to A plus A to C. And then because we've got A to C here, we already know something about AC. We know that if we're going from A all the way to C, then we've got to take up all of those 7 parts, and we know how much of those 7 parts AB has, and we know how much of the 7 parts BC has. So if we try to find AB here on the diagram, I'll mark that in red, then a journey to get from A to B is AO plus OB. A to O is going to be minus 2A minus B, because we're going in the opposite direction to what OA would have been, plus OB, which is thankfully given. And then neaten that up a little bit. A's first, we've got A plus B. Now, the nice thing about it is we've basically done what we need to do, because if you think about it, if A to B is A plus B, and that was worth 2/7 of the whole of A to C, then we've got the answer, haven't we? And think of it this way, we've got 2/7 of AC is AB, I'll do it this way, and therefore 2/7 of AC is AB, which is A plus B. So if we multiply both sides by 7 and divide by 2 to get rid of the 2/7 on the left hand side, we'll have 7/2 of A plus B. And then all we have to do is substitute it into here, and then we've got our answer. So we'll have OC equals OA, which is 2A plus B, which is given here, plus AC, which is 7/2 of A plus B. And all we do is just multiply these out. So we've got 7/2 of A plus 7/2 of B. And then if you do the A's first, 2 is the same as 4/2 and 7/2 is 11/2. And then B, you've got 2/2 here because you've got 1B, so 2/2 and 7 more is 9/2. And I'd probably take out the half as a factor here, and I'll be left with 11A plus 9B. I think the difficult part of that question was the ratio part. Another way of doing it is you could say that A to B is like got 2 of those parts and B to C has 5 of those parts, but as long as you know then that there's 7 parts from A all the way to C, then you should remember that once you've got AB, you can say that AB is 2 of those parts out of a total 7 of AC, and if you wanted BC, then you'd say, well, that is 5 of those 7 parts of AC. So I'm afraid vectors can get quite tricky, especially when there's ratios involved. And again, this answer here, I would be quite worried if that was the answer in the paper, but as far as I'm concerned it is correct, but you know, the numbers aren't easy. Now, I'm not massively happy with the wording of the question. On the grid, construct the graph of x squared plus y squared is 16. That implies to me that you'd have to use a compass. So maybe that's giving you a clue. I'd rather it just said, you know, graph x squared plus y squared is 16, for example. Now, I guess what some students will start doing is put values into this equation here. So for example, they might just say y squared is 16 minus x squared and start putting values in. Well, we can have a little look at that and see if it gives us any clues. By the way, this is actually a circle centre 0, 0, radius 4, because the equation of a circle is x squared plus y squared is r squared, where r is the radius, and that's the circle centred around the origin, by the way. But if you didn't know that, then you would just put values in. So if you said x equals 0, then you'd have y squared is 16, so y is plus or minus 4. So you'd have a 4 here and a minus 4 there. And then if you said, for example, x equals 1, you'd have y squared equals 15. And if you did the square root of 15, let's look at that on our calculator, because don't forget it is a calculator paper. You'd have 15 to the power 0.5, and you get 3.87 plus or minus. So you could start, you know, plotting these values here. So if you got 3 here, 3.2, 4, 6, 3.87, that's the plus value, and then here you've got the minus value. And you could carry on doing that, and it would take you a long time. You'd probably run out of time. So it's probably best to understand that this is the equation of a circle at the centre, radius r. So if r squared is 16, which it is in this case, then the radius is 4. So basically you're going to be constructing a circle of radius 4. Now, I don't have a compass with me, so I'm going to give a good try at doing this first, and then we'll go from there. So there's my effort for a circle, and I'd use your compass, a pair of compasses. That would be a good idea. So that's that part done, and then now we've got to find estimates for the solutions of the simultaneous equations. Well, if we have to look at the line y equals 2x plus 1, then it has an intercept of 1, which is here, and a gradient of 2. So that means every one I go along, I'll go up by 2 here. So there's another point, and I can just put a line through here, because I only need 2 points to plot a straight line. So let's go with that. And I can move this here, and I'll put it through those 2 points as best as I can. And we can see from here that it cuts here and here. Now, if you were doing this accurately in the exam, i.e. the circle would look a lot better than mine, then all you have to do is find estimates for the solutions of these simultaneous equations. Well, when it wants the solutions, it wants them in x and y, don't forget. So And the other important thing is we're really seeing where the straight line cuts the circle. That's what it means by solutions of the simultaneous, is where they meet. So we need to use our estimation here. So very carefully, we're going to use our ruler and do a dotted line here. And I would say that's at around the 1.4 mark. So I'd say x is approximately 1.4, and then the corresponding y value, well, that looks around 3.8, and I'll call that coordinate A. So we'd have 1.4, 3.8, and then our next corresponding value of x and y's will be this one here, and that looks like x is around negative 2.2, and the corresponding y value here looks like about negative 3.4. So let's just put that to one side, because that's what you'd need to do in the exam, and that will be the answer, I'm pretty sure. But if we can just do it algebraically and take ourselves through that, that will satisfy us that we can use algebra as well, even though we wouldn't for this particular question. So if we had x squared plus y squared was 16 and y was 2x plus 1, well, we want to see where they intersect, so we'd substitute this 2x plus 1 into here, and we'd have x squared plus 2x plus 1 all squared is 16, which will give us x squared plus 4x squared plus 4x plus 1 is 16. So we'd have this here, which we could then put into the formula, and we'd have b squared 16 minus 4 times 5 times negative 15 all over 10, which would be minus 4 plus or minus 16 plus 300 all over 10, which would be minus 4 plus or minus root 316 over 10, and then 4's goes into 316 79 times, and then we can halve the top and halve the bottom, and we should be there. So if we put those values in as x, let's see what we'd get. And there'd be the values. So I'd do x's from here. I would have negative 2 plus root 79 all divided by 5, and then that would be this corresponding value of x. Then I would substitute that in here, so I'd times the value of x by 2 and add 1, and I'd get this value. Then I would do negative 2 minus root 79 all divided by 5. That would give me this value of x. Then I would times by 2 and add 1, and I'd get these values. So I'm just interested to see just how close we were. So to one decimal place 1.4, to one decimal place 3.8, to one decimal place negative 2.2, and to one decimal place negative 3.4. So that's a nice end to this paper. So I hope this paper's gone okay for you. Some of the questions I've spent a long time on, that's fine. If you find that's too much, then just go to the particular question you want. And if you get the concept, just go, a little, play the question forward to the end so you can see some of the workings, and then you'll get an idea of what's gone on. But I'd rather give more explanation than less. So I'm not going to assume that I'm just pitching this to an audience of people who are getting A's and, A's and A stars. It's perfectly okay to get a B and a C on a higher paper. So I need to go a little bit more slowly to meet the entire audience. If you're at the very top end of A star, then you can just flick through these questions reasonably quickly, okay, and just get an idea of what's going on. But if you're a B grade candidate, then I suggest you just take your time and practice each of the questions, carefully and slowly, so it sinks in. Okay, so I hope that paper went okay for you.